students, I am Ekta. Children, we know sets. The natural question is, what can we do with sets? What are natural operation on them? What can we do with sets? We can pick an element, but then which element? There are many in general. Hence, picking an element is not an operation on a set, but as we did with addition, subtraction, etc. We can try and think of operations that combine two given sets to get a new set. How can we do this? A simple way is to put the two sets together. This gives us a new set and exactly one set, so it is an operation. We could pick out exactly the common elements of the two given sets. That's an interesting operation too. Learning outcomes. To understand and perform set operations. To apply set operation in the Venn diagram. Keywords from this lesson: set, Venn diagram, universal set, complement, union, intersection, difference, symmetric, disjoint. Children, when two or more sets combine together to form one set under the given conditions, then operation on sets can be carried out. We can visualize the relationships between sets and set operations using a Venn diagram. John Venn was an English mathematician. He invented Venn diagrams, which pictorially represent the relation between sets. Venn diagrams are used in the field of set theory, probability, statistics, logic, and computer science. Universal set. A universal set is a set which contains all the elements of all the sets under consideration and is usually denoted by U. For example, if we discuss elements in natural numbers, then the universal set U is the set of all natural numbers. U is equal to X, X belongs to N. If A is equal to Earth, Mars, Jupiter, then the universal set U is the planets of the solar system. Complement of a set. The complement of a set is the set of all elements of U that are not in A. It is denoted by A dash or A complement. In symbols, A dash is equal to X, X belongs to U, X naught belongs to A. Venn diagram for the complement of a set. For example, if U is equal to all boys in a class and A is equal to boys who play cricket, then the complement of the set A is A dash is equal to boys who do not play cricket. Example, if U is equal to C, D, E, F, G, H, I, J and A is equal to C, D, G, J, find A dash. Solution: U is equal to C, D, E, F, G, H, I, J. A is equal to C, D, G, J. A dash is equal to E, F, H, I. Union of two sets. The union of two sets A and B is the set of all elements which are either in A or in B or both. It is denoted by A union B and read as A union B. In symbol, A union B is equal to X, X belongs to A or X belongs to B. The union of two sets can be represented by a Venn diagram as given below. For example, if P is equal to Asia, Africa, Antarctica, Australia, and Q is equal to Europe, North America, South America, then the union set of P and Q is P union Q is equal to Asia, Africa, Antarctica, Australia, Europe, North America, South America. Example, if P is equal to M, N and Q is equal to M, I, J. Represent P and Q in the Venn diagram and find P union Q. Solution: given P is equal to M, N and Q is equal to M, I, J. From the diagram, P union Q is equal to N, M, I, J. Intersection of two sets. The intersection of two sets A and B is the set of all elements common to both A and B. It is denoted by A intersection B and read as A intersection B. In symbol, A intersection B is equal to X, X belongs to A and X belongs to B. The intersection of two sets can be represented by a Venn diagram as given below. For example, if A is equal to 1, 2, 6, B is equal to 2, 3, 4, then A intersection B is equal to 2 because 2 is the common element of the sets A and B. Can we determine N of A intersection B in terms of N of A and N of B? This seems too difficult, but what about N of A union B in terms of N of A and N of B? Notice that all the elements in A are in A union B and all the elements in B are also in A union B. Can we say that N of A union B is equal to N of A plus N of B? Unfortunately, not. Consider an element common to both A and B. Of course, it is in A union B, but it is counted both in A and B and we don't want to count the same element twice in A union B. So indeed, N of A union B is equal to N of A plus N of B minus N of A intersection B. But then it is easy to see that n of A intersection B is equal to n of A plus n of B minus n A union B. So, between the union and the intersection, we need to know one to determine the other given n of A and n of B. Example, let A is equal to x, x is an even natural number and 1 less than x less than or equal to 12 and B is equal to x, x is a multiple of 3, x belongs to n and x less than or equal to 12. Be two sets, find A intersection B. Solution. Here A is equal to 2, 4, 6, 8, 10, 12 and B is equal to 3, 6, 9, 12. A intersection B is equal to 6, 12. Example, if A is equal to 2, 3 and C is equal to null set, find A intersection C. Solution. There is no common element and hence A intersection C is equal to null set. Difference of two sets. Let A and B be two sets. The difference between sets A and B is the set of all elements which are in A but not in B. It is denoted by A minus B and read as A difference B. In symbol, A minus B is equal to x, x belongs to A and x not belongs to B. B minus A is equal to y, y belongs to B and y not belongs to A. Venn diagram for set difference. Example, if A is equal to minus 3, minus 2, 1, 4 and B is equal to 0, 1, 2, 4, find A minus B, B minus A. Solution. A minus B is equal to minus 3, minus 2, 1, 4, minus 0, 1, 2, 4 is equal to minus 3, minus 2. B minus A is equal to 0, 1, 2, 4 minus 3, minus 2, 1, 4 is equal to 0, 2. Symmetric difference of two sets. The symmetric difference of two sets A and B is the set A minus B union of B minus A. It is denoted by A delta B. A delta B is equal to x, x belongs to A minus B or x belongs to B minus A. Example, if A is equal to 6, 7, 8, 9 and B is equal to 8, 10, 12, find A delta B. Solution. A minus B is equal to 6, 7, 9, B minus A is equal to 10, 12. A delta B is equal to A minus B union B minus A is equal to 6, 7, 9 union 10, 12. A delta B is equal to 6, 7, 9, 10, 12. Example, represent A delta B through the Venn diagram. Solution, A delta B is equal to A minus B union of B minus A. Disjoint sets. Two sets A and B are said to be disjoint if they do not have common elements. In other words, if A intersection B is equal to empty set, then A and B are said to be disjoint sets. Example, verify whether A is equal to 20, 22, 23, 24 and B is equal to 25, 30, 40, 45 are disjoint sets. Solution, A is equal to 20, 22, 23, 24. B is equal to 25, 30, 40, 45. A intersection B is equal to 20, 22, 23, 24 intersection 25, 30, 40, 45 is equal to null set. Since A intersection B is equal to empty set, A and B are disjoint sets. Example, from the given Venn diagram, write the elements of A, B, A minus B, B minus A dash, B dash universal set. Solution, A is equal to A, E, I, O, U. B is equal to B, C, E, O. A minus B is equal to A, I, U. B minus A is equal to B, C. A dash is equal to B, C, D, G. B dash is equal to A, D, G, I, U. Universal set is equal to A, B, C, D, E, G, I, O, U. Points to remember. The union of two sets A and B is the set of all elements which are either in A or in B or both. It is denoted by A union B. The intersection of two sets A and B is the set of all elements common to both A and B. It is denoted by A intersection B. The symmetric difference of two sets A and B is the set A minus B union of B minus A. It is denoted by A delta B. If A intersection B is equal to empty set, then A and B are said to be disjoint sets. The symmetric difference of two sets A and B is the union of A minus B and B minus A. Thanks for watching. Like, share and subscribe.